Today we have to see what are the basic fundamentals and what are the common principles behind the strength of a material. Now we have to see about what are the different types of a strength. In engineering, the term strength is defined as different categories and depends upon the direction of the load applied. That means the first one is a compressive strength, and second one is a tensile strength, and third one is a shear strength. What is a compressive strength? A load or a force which is acting towards the body, which is known as a compressive strength, whereas a tensile strength, the force which is uh, pulling the load, it's pulling the total body outwards, which is a tensile strength, whereas a shear strength is known as a load which is acting tangentially to the body, which is a shear strength. It all depends upon the type of loading, right? In this, we have to see what is mass and gravity, and strength and stress, and after that strain and a modulus of rigidity. What are the flexural loads? What is fatigue strength? And what is meant by Poisson's ratio as well as creep, right? First, we have to see about gravity. The mass of our object is defined depends upon its acceleration when a force is applied. It can be expressed by F is equal to m into A. It's not for a gravity, right? Gravity is normally indicated by a force which is acting on a structural. It is indicated by m, right? Gravitational force, which is m. It is defined by the formula F is equal to m into g in terms of gravity, where the gravity value g is 9.81 meter per second square, right? The gravitational force on an object is called its weight, right? Always the weight due to gravity it acts downwards. No, thus an object will have a weight of 9.81 Newton per kg of mass. It shows the clear representation of what is compressive, tension, and a bending and shearing, right? First of all, we have to see that cylindrical object. If a tensional force acts, means it's a pulling force, right? Whereas compression means pushing towards the object, right? Flexural means, it's a good example is a bridge. It's supported at the bottom, whereas a load is acting at the top. It automatically leads to bending, right? Whereas shear means tangential force acting on the surface of the body, right? Tension and compression, small example which relates to a bridge. Now we have to see strength under stress. This is the testing equipment, whether we have to check the strength by using a tensile machines. Now, what is a shear stress? Shear, it is represented by tau, measure of an internal resistance of a material to an externally applied shear load. It may be represented by load by area. It will be indicated clearly that load W by area resisting shear, which is A. Next, stress. Before we going for analyzing of a concerned beam or a stress, first we have to know what is stress. This is a measure of an internal resistance in a material to an externally applied load. Due to external load, the pressure, which is stress, which is created inside the material, it is the measure of internal resistance in a material. For direct compressive or tensiling loading, the stress is designed sigma and is defined as W by A, stress which is equal to load by area. These are the different types of stresses. First one is compressive and second one is tensile. We already clearly stated what is compressive and what is tensile, right? These are some of the measurings of strain. I already told you that stress is the internal resistance in a material due to external applied load. What will happen once an external load is acted inside a material? Definitely it leads to some deformation. That deformation is named as elongation or deformation. That elongation may be in length phase or in diameter phase. That extension is measured as strain. Strain is equal to extension by length. It also be named as extension is change in length or change in diameter by original length or original diameter. That can be measured by using some equipments. In this, stress is analyzed by load by area, by using load by area, how much of load acting towards certain area, right? Unit area. Yeah. Strain, it is a measure of force, but is a measure of deformation produced by the influence of stress. Due to stress, how much amount of strain is created inside the concerned body. For tensile or compressive loads, strain is equal to increase in length by original length. Normally increased in length or change in length, whatever it may be, but strain is always be change in its length, right? Whereas it is a dimensionless property. Why? Because change in length is also in mm or centimeter or meter, whereas original length is also in meter or mm or centimeters. So due to that, it both get cancelled, so it's a dimensionless member. So CS strain is represented as shear displacement by width, right? It represented in radians, right? It is the best example for showing the CS stress, sorry, area resisting shear, whereas the force acting from left side to the object, whereas at the bottom from right side to the left side. Due to that, shear stress is created inside the body. It is the relationship between the stress and strain. Stress is always directly proportional to strain, which is the elastic deformation, whereas plastic deformation, it's a permanent deformation will occurs, right? These two comparisons will clearly shows it's the relation for stress and strain in steel. What will happens for the initial phase, the steel, when stress is applied, an elastic state is occurred. At one point, an yield stress is occurred and a plastic state will due. After that certain period, the failure will definitely occurs. right? Now we completed what's strained, and we have to move to modulus of elasticity. If the strain is elastic, what it means? Hooke's law may be used to define Young's modulus, which is also named as modulus of elasticity. Young's modulus is also called as modulus of elasticity or stiffness, and it is a measure of how much strain occurs due to given stress, right? Because strain is dimensional, always wrong. Young's modulus has the units of stress or a pressure. By Young's modulus or the modulus of elasticity, it is denoted by capital E, and it is related by stress by strain, whereas stress is load or a weight, whereas strain is a deformation or per unit area, right? After that, we have to see about shear stresses and strains. A force which is acting at the bottom and the top towards the object, which is the shear force, where the strain is the degree or angle produced to the actual of the body, right? That is a shear angle. Then what is an ultimate strength? The strength, which is also always be an ultimate, no? So strength of a material is a measure of stress that it can take when it used. The ultimate stress is the measured stress at failure, but this is not normally used for design because safety factors are required. No, the ultimate strength is a measured stress at failure, but this is not normally used for design because safety factors are required. In normal, the safety factors are defined by ultimate by permissible stress. What it means of permissible? A body having an elastic limit, no, that is a permissible stress, whereas ultimate means maximum load capability, that is also named as stress at failure by stress when loaded, right? This is named as ultimate strength, where it clearly we have to know about what is permissible stress. Permissible means it's a limited. This is steel test in laboratory indicates to know what's the extension which occurs when uniform loading is applied, right? Extension comes from 0 to up to 3, right? From applying load of 10,000 Newton up to 3,000 to 4,000 Newtons. What's the extension occurrence when categories of loading is applied? Which is the energy absorbed or strain energy. Energy absorbed is also defined as strain energy. Area, common area, which is an average stress into final strain. E is always energy absorbed, and work done, how much amount of energy given to do the work, right? Which is an energy absorbed principle, which is final strain. This is non-linear stress strain graph indicating how initial tangential models and sectional models of stresses we are calculating. It's a gradiential stress initial tangential model with the second model. How stresses SS strain is acting in a non-linear categories of initial positioning. After that, we have to see about flexural stress. What is fractural stress? Fractural, it's a deflection. Deflection occurrence from a normal position to the change of position. That is flexural. Let us take an example. An object having a rectangular object which is having a length, breadth and a depth. No? When a load is acting at the top of the object, there should be a gradual compression which is occurred due to gravity at the bottom. That deviation from the actual position is named as deflection and it is named as x. That is flexural strength. These are the common units of stress and strain. The basic unit for force and load is Newton. No, it's a common term. We have to represent the force as well as load in Newton, which is equivalent to kg meter per second square, whereas 1 kilogram is equal to 9.81 Newton, whereas kilogram is represented in kg. In industries, the units of stresses are normally Newton per mm square. It's a common standard, whereas we are also following the same industrial standards as Newton per mm square, but this is not a base unit for calculation, right? And we go for mk's unit for pressure is a pascal, whereas 1 pascal is equal to 1 Newton per square meter. Commonly we are using mk's units for calculating the pressures where it is in pascal, whereas 1 pascal is equal to 1 Newton per square meter. And next one is a pressure and stress have the same units. No, it's a pressure as well as a stress, both representing the internal occurrence due to external force or load. So the pressure and the stress both are common, right? Which is represented as 1 megapascal, which is equal to 1 Newton per mm square, right? Then we all know about strain. Yeah, strain has no dimensions. It is expression as a percentage or in micro strain. No, because strain have no unit, so it can be expressed as a percentage, a micro strain. Whereas a strain of 1 is extension of 1 part per million, right? 0.2 percentage is equal to 2000 mus. And next one we have to see is fatigue. It's the biggest example for showing what is fatigue. No, what it means, what this picture indicates. What is a fatigue? Fatigue is completely collapsing stage due to poor designing. Before constructing or designing a bridge or some other infrastructure, we have to analyze what is the common factors which are influencing those parameters, right? What is the stress acting commonly on a body and what will be the strain? If it extends, it definitely leads to a failure, right? The bridge is constructed without the proper infrastructure calculation developments, it leads to develop fatigue, right? Fatigue. And next one is a Poisson's ratio. What it means, Poisson's ratio? This is a measure of amount by which a solid spreads out sideways under the action of load from above, right? It is commonly represented as lateral strain by vertical strain. What it means of lateral strain? The change of deflection in terms of diameter or depth, which is named as lateral, whereas longitudinal indicates change of deformation in length. So lateral indicates change in its diameter or breadth or depth, right, which is lateral. To vertical strain, and it is also a dimensional. We already clearly stated that strain has no units. Yeah, in this, a material like timber which has a grain directions will have a number of different Poisson's ratios corresponding to loading and deflection in different directions, right? Timber having a finite grain directions which have a number of different Poisson's ratios just corresponding to loading and deformation in different directions. This is to calculate the deflection if the proof stress is applied and then partially removed. It's a sample for proof stress of 0.2 percentage. Yeah, every material having a stress which it observes for a certain period, and at a certain stage, it yields some stress. After that, a plasticity state will occurs, and at one stage definitely it leads to failure if we didn't avoid overloading or a maximum loading. So it's a sample for loading up to 0.2 percentage of proof stress and then underload to a stress, right? Here is a sample of the curve between the stress and the strain from yield plastic and up to a failure loading. In common, all we must know, in universal testing machine, we have to check a sample or a specimen of an iron rod to check whether at what condition or at what phenomenon the common stress, yield, ultimate and the breaking stresses are occurring. Initially, the rods are clamped in the chuck and a gradual load is applied. Due to gradual loading is applied on the bar, it gradually gets extended. For example, the length of the rod is 20 mm and the diameter of the rod is 2 mm. Due to gradual loading, the length of the rod gets extended. Approximately it extends up to 1 mm, means approximately 21 mm the rod is extends. Automatically the diameter of the rod gets decreased. It's 2 mm rod, it's approximately changes its diameter from 2 mm to 1.8 mm or 1.7 mm. So due to external load is applying, already the both the ends of the rod is completely blocked. The center portion of the object gets extended, and at a limit some extension it gets bulging and yield stress is occurred, that we have to mark as yield. And before the breaking position, the plasticity state occurrence and finally it gets breaked. The real-time example for these proofs we get from the universal testing machine. We get a great sample, And from the overview of these topics, now we have to conclude that what is stress, what is a strain, and modulus of elasticity, what is a gravity, and what is a flexural load, and what it happens to a body when flexural load is applied, and what is a Poisson's ratio, and finally it's a creep. The two major similarities and the most different categories of stress and strain, we have to know that it is a measure of internal resistance of a material to externally applied load, which is a stress, which is named as load by area, whereas strain, it is measure of deformation produced by the influence of stress, right, for tensile or a compressive. Already we noted that tensile and compressive are a slight changed contents, whereas tensile indicates load acting towards outwards, right, whereas compressive load indicates load acts inwards, that is towards the material. Both the contents are measured using some special equipments, whereas shear is a tangential force which is acting on the body, whereas elastic and plastic deformations are occurred in stress and strain relationship, whereas in plastic deformation it's vice versa, and whereas in plastic deformation it occurs as permanent deformation, right? This is the common stress strain curve for the steel, right? Fine. Thank you all.